Determine whether the data in the table is an example of direct, inverse, or joint variation. Then identify the equation that represents the relationship. So let's just think about what direct, inverse, or joint variation even means. So if you have direct variation, so if y varies directly with x, it literally means that y is equal to some constant multiple of x. Or if you divide both sides of this by x, it means that y over x is equal to k. So the ratio between y and x is a constant. And you could go the other way around. You could also say that x is equal to some constant, not going to be the same constant, times y. Or that x over y is going to be equal to some other constant. So these aren't necessarily the same k. All I'm just saying is that it's a constant relationship. These are all examples of direct variation. Or I should say inverse variation is to some degree the opposite, depending on how you view the opposite. And before I even talk about that, let's think about the telltale signs of direct variation. If x increases, y should increase. So if x increases, let me do that in the same yellow. So the telltale signs of direct variation, if x increases, then y will increase, and vice versa. The other telltale sign is if you increase x by some factor. So if you have x going to 3x, then y should also increase by that same factor. And we can see that with some examples. So I mean, you could pick a k. Let's say that k was 1. So if y is equal to x, if x goes from 1 to 3, then y is also going to go from 1 to 3. So that's all we're talking about here. And let me actually, y should actually go to 3 times y. That's what I'm talking about. If you triple x, you are also going to end up tripling y. Inverse variation, you have y being equal to some constant times 1 over x. So instead of an x here, you have a 1 over x. Or if you multiply both sides by x, you get x times y is equal to some constant. And you could switch the x's and the y's around as well for inverse variation. Now, what are the telltale signs? Well, if you increase x, if x goes up, then what happens to y? If x goes up, then this becomes a smaller value because it's 1 over x. So then y will go down. Then y will go down. And if you take x, and if you were to say increase it by a factor of 3, then what's going to happen to y? Well, if you increase this by a factor of 3, you're actually going to decrease this whole value by a factor of 1/3. So y is going to go, so then you're going to have 1/3 of y. So these are the telltale signs for inverse variation. Now finally, they talk about something called joint variation. And this one you won't necessarily see in an introductory algebra course. But joint variation deals with more than one variable. So if I told you that area of a rectangle is equal to the width of a rectangle times the length of a rectangle, this is an example of joint variation. Area is proportional to two different quantities. So the main telltale sign here for joint variation, frankly, is you're going to be dealing with more than two variables. Joint variation. So when you look at this example, they're only giving us two variables, so you can rule out joint variation just right from the get-go. And let's look at the telltale signs. So as x is increasing, as x goes from 1 to 2, what is happening to y? Y is going from 12 to 6. So as x is going up by a factor of 2, y is going by a factor of 1/2, or y is being multiplied by 1/2. As x goes from 1 to 3, being multiplied by 3, y is being multiplied, or I guess you could say is multiplied by 1/3. So it's definitely not direct variation. As x increases, y is decreasing. So it's definitely not direct variation. And then really, you could just rule out, since we've ruled out the other two, you could probably guess this is going to be inverse variation. But we can validate it. When x increases, y is decreasing. When x increases by a certain factor, y is increasing by 1 over that factor, so it's actually decreasing. So if you go from 1 to 3, if x is being multiplied by 3, then y essentially becomes 1/3 of its original value. When x is 1, y is 12. When x is 3, y is 4. So we have inverse variation at play. Now, they ask us, identify the equation that represents the relationship. Well, we know with inverse variation, the product of x and y need to be equal to some constant. So if we take x times y over here, so let's make another column here. Let me call this the x times y column. Well, 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. 4 times 3 is 12. So clearly, in every situation, x times y is a constant, and it is 12. So the equation that represents the relationship, it is xy is equal to 12. And that is clearly an inverse relationship.